Hi everyone, we're going to evaluate the limit if it exists. Of course, if you plug in 0 here, it's not going to exist because you divide by 0. So we're just going to clean this equation up a bit so we can find the limit. Right now, the domain can't be 0, so we can say h cannot be 0. So let's clean this up. And what I'm going to do is look at the numerator and have my common denominator. So my common denominator is going to be x plus h squared times x squared. That's your common denominator. You have to take both of those. And to take care of the numerator here, that just means we need an x squared for this. So if we want an x squared here, we have to put it here. So that put x squared here. Here we need the x plus h squared to match up our denominator. So we also have to put it in the numerator. Be careful because we have this negative. So that's what the numerator is for this complex rational. Then we have the h. Anytime you see something like this, you can just move that h up here. So let's just go ahead and do that. We're going to go ahead and put that h right up here with that. Let me rewrite it a little bit. So now we have the limit as h approaches 0 of x squared minus, now let's use our factoring facts. It has this and write it out like that. So that's going to be x squared plus 2xh plus h squared. And I'm going to go ahead and move this guy up front like that. So this is going to be hx squared times x plus h squared. All right, now cleaning up the numerator, let's see. Let's write it out. Limit as x approaches 0. Let's write it all out. X squared minus x squared minus 2xh minus h squared. Be careful, you have to distribute that negative. All right, all over hx squared times x plus h squared. All right, so basically I did that to cancel out the x squares here. So now I can rewrite this, and what I'm going to do is pull out this h. I'm going to pull it out and rewrite this as the limit as h approaches 0 of negative h. I'm actually pulling out a negative h, 2x plus h. Divided by hx squared times x plus h squared. So what happens is, again, our h can't be 0, but we can cross this out. And now we're going to have, make sure you write the limit as h approaches 0 of negative 2x plus h divided by x squared times x plus h squared. Now, at this point, you can plug in 0 for h. So everywhere there's a h, we're going to plug in 0. So you're going to get negative 2x plus 0, x squared times x plus 0 squared. And this is going to equal negative 2x divided by x squared times x squared. So this is equal to negative 2x divided by x to the 4th, which is reduces to negative 2 divided by x cubed. You got to simplify these x's. All right, and that's it. Thank you. Have a nice day. Bye-bye.